All right, so this is me analyzing the results from the most recent taped post experiment. So I'm going to show you how I go from just the raw files to the nice plots. And I'm going to be doing it live. I haven't seen the results yet, so let's get cracking. First thing I'm going to do is I'm going to go to my Python IDE. I have Spider. You can use whatever you want. Then I have made two different programs. The first, I have Experiment Viewer. And all this is going to do is just show all of the spectra we record in quick succession. So we could basically watch a video of the entire experiment. And from that, we could determine which peaks survive the entire ordeal, which ones you think we can track the whole time. And some of them might, go off screen or change their shape and not be a Gaussian anymore, or something like that. So all I really have to do is point it to the correct folder and hit go. So here I have the tape post folder, and these are all the spreadsheets. First thing I'm going to do is I'm going to rename these to put them in the right order. So the program's going to open them up in alphabetical order, but I could just number them 1, 2, 3, 4 in the order I want. So heating ones first. So where is rename? So I'm going to call it 1 first heating. And then the first cooling is going to be 2. Second, the third one, and 4. Okay. And furthermore, I'm currently in a folder called taped posts. And just how I like to organize things, I'm going to have one folder for the data. I'm going to make another folder for results. That'll come in handy later. For now, let's grab all these, put them into data. There we go. Now what I could do is right-click on the folder. I'm going to copy the address as text. And I'm going to paste it into data path here. It's just the path to the folder. Then a little quirk of Python, this first slash here, you need to put a second one. There we go. Then it should be as simple as hitting run, and we're going to head over to the plots tab, or however you view the plots in your IDE, and we'll watch it go. Takes time to do it, of course. Usually takes a bit less time than this. Oh, there we go. Ah. Yep, that's an issue on my part. So from a previous thing, I had decided to... Oh boy. That's important. Oh yeah. Okay, let's see what we're dealing with here once that goes away. And no wonder it took a while. You bet. 230. Alright. And look at us going back there. No wonder it took a while. Like I said, I'm doing this live. Anyway, something's clearly wrong. I'm just gonna halt it. Okay. Now all this should be doing is plotting. Yeah, look, at first heating, it's grabbing power over wavelengths, which is what we want. That's all fine. And then here, once we hit second cooling, it's not doing wavelength anymore. Yeah, second heating's fine. Second cooling, something's up. So something's wrong with that CSV. I'm going to close all of these butts because that's a lot of RAM. Let's open up second cooling, see what happened there. Yeah, I don't think this. Let's compare it with one that worked. Oh. Yeah, see, I don't think this one was saved correctly. You'll notice that here, in the proper one, we have wavelengths going down the first column, right? But over here, we don't. I imagine this is temperature. So I don't think you halted the program correctly. I think you just hit stop instead of stop and transpose. We need to transpose this entire thing. Let's do that. Oh, how about we try a new sheet? That won't work because it's CSV. Paste the transpose. Thank you. Took me long enough. Okay. So that should now look like our other one. First heating. Yeah, temperatures, and then rows of zeros, and time, and wavelengths. Okay, so yeah, be sure to hit that stop and transpose button and not just halt the program. Okay? Alright, so let's close that. This one, we're going to have to delete that whole sheet. Then we're going to save. I'm just going to open it up again just to make sure that it's fine. So second cooling. Boom, there it is. And man, you have a lot of entries here. You know what? That's fine. You took a lot of entries. We'll analyze them all. That'll just make this video a bit longer while it thinks. Okay, let's go back to Spider. Now that we fixed that problem, we'll try this again. And it's going to take a while because we have a lot of data. See, you have to. Oh, there we go. See, first cooling. Oh, I forgot to fix the thing. Hold on. Oh, remember last time you saw data going out of bounds? That's because I have a fixed Y limit here. Which is handy sometimes, but for now I'm just going to comment that out. Now I should be able to see the whole thing every time. Now here we go. What we're looking for is maxima that either disappear or go off screen. Because if any of them do that, we can't track them, so we shouldn't tell the program to try to track them. So far, everything's pretty stable. except for the last one. Okay, I'm going to assume that that last one was, again, you must have halted the program in an improper way or something. So we're not going to include that last one. Other than that, the extremists seem pretty stable. So I'm gonna go back to my file. Saying number 3, tape post, data, last one. And I'm gonna do a bit of a sin and delete that row. That's our little secret, okay? Digest. Okay, that's all good to go. I'm gonna run it one more time just to make sure that everything's good. I'll probably cut this one out. Let's see. Great. So we know that peaks didn't appear or disappear or go off the side. So that's that phase done. Now we go over to experimental plotter. This is the big program that does all of my analysis. Now the first thing, well, let me give you a little bit of an overview of the logic. So what's going to happen here is that for each extrema, we're going to do a first initial curve fit for the very first temperature recording and put all the parameters into here. Okay? What the program does is that it's going to start with this one in the first file, and then it's going to apply a curve fit to that area and get a new set of parameters that tell us where the center is. It'll save us where the center is, and then it'll use those parameters as the starting point for the next one. We do another curve fit, save where the center is. That's the parameters for the next one to start with. Okay? Pretty much just loop that for all of the files, for all of the extrema, and then we plot the centers over the temperature. Okay? So first thing is we need those initial values for all of the Gaussians. So let's do that. All this is from my previous experiment. I'm just going to get rid of that. So the initial curve fits we can do in Igor. There they are. Wowie. And then I'm going to, once again, open posts, data, first heating. Could have just left this open if I was smarter. And from here, I'm just going to grab the first spectrum and paste it. There we go. Okay, so we could definitely work with this peak right here, this peak right here, and this peak right here. I don't know about these guys. I mean, we'll try. First, I'm going to move these markers over to here. Analysis, curve fit, type Gauss, Y data, wave 1, X data, wave 0. Data options, the cursors, right? We're just grabbing the Gaussian looking bit. Let's see. That should do it. Oh, we can see the blue line, nice fit. Okay, and here it returns all the coefficients. So I like to pull them up side by side. Okay, so the first set of parameters. How the format for this works is that outer bracket, that's the list of all the parameters. For each peak is going to be like a sub list, right? So here's our first entry, and it's the same order as in Igor here. So 4.0 9 e negative 5, 3.4 e negative 5, 1499, 10.6. And again, this is just the starting point for Python's own curve fit, so it doesn't need to be precise. And then importantly, we also need to mark down how many points we used. So in this example, you can see here we have 0.281 and 184. So that's 3 less than 100, so 97 points. And the importance of that is that we can't apply a Gaussian curve fit to the entire range of data. Of course, right? It's not just one curve, it's a lot of curves. So we have to, this is how I tell it how wide of a domain to select, right? Now we're going to repeat that for all the other ones you want to do. This. So the next one, something like this. Do it. Nice. So again, next element. So we do another list. 0.00008. Negative 0.00013. 1514. 17.8. And here, this is where I don't trust my mental arithmetic, so I'm going to bring out my calculator on the side. 0.439 minus 346. And I'm looking at these values here. We used 93 points in that one. Okay, let's see if we can apply a fit to this. I guess is not hopeful. Let's see. You know what? We'll run with it. We'll see. Let's see what happens. Comma. Next one. 7.55 e negative 5. 3.89 e negative 5. 1533. 12 point. And on that one, 15 minus 549, we use 66 points. Remember seeing that middle one warping a bit, so yeah, let's just skip to the end here. .02 e negative 5. 5, 3.11. And then the number of points used. Okay. So here I'm doing 4 extrema. I'm doing this one, trying this one. Again, I kind of doubt it. And this one. So 4, we only need 4 names. A, B, C, and D. All right. We shouldn't need Igor anymore. Yay. Again, I just grabbed the file path, or let's say the folder path, to where I have the data. So I'm just going to paste it here again as a string. Again, we need that second backslash here. Then results path. This is going to be the folder we wanted to export all of the results to. So that's why I made the results folder earlier. Copy address. Boom. Second backslash. Okay. Let's talk about some other parameters here. Do locations plot is just telling it that I want to make those nice locations over temperature kind of final pictures that you're familiar with. So we want that. Do export. This is going to save all the results to CSVs and save the pictures. I don't want to do that until I make sure everything's working, we're not getting errors. So I'm going to save that false for now. Individually graphed extrema. If one of your extrema are looking a bit strange and you want to check how the curve fit's applying to them, you could run that function. Maybe I'll show you what to do later. For now, I'll leave it blank. Spectra. Okay. This is a subsetting for this. Basically, what this does is it'll graph all of the spectra and it'll highlight the curve fit range it's doing and then graph the curve fit over it. And this will fix the y-axis for that process. But we're not going to be doing that, so it doesn't matter. Band files. If you know you have problematic files, like a while back, I had one in which the entire pattern flatlined and then came back, so we couldn't fit over that. So I had to skip that one. If you have any files, we could put the names in there, but we're not going to do that right now. I'm not going to run through I'm not going to do a tutorial on how all of this works, because that would take ages, and I think I've done a decent job of commenting out. One important thing I will mention is down here, right? So I have this green big ol' string here. And it's about grabbing the temperature, right? So obviously we're plotting this as a function of temperature, so we need to grab the temperature from the sheet. And if we open up the sheet, here we can see it's saved in the very first row in this case. Right? But here's the crux, right? If you used the other temperature sensor, it could be down in the second row instead. So we need to point this to different places. So basically, all you would need to change is here, where it says experimental of 0i. What that currently means is, okay, we're going to go to the experimental array. We're going to go to the 0th row, right? It's 0 indexed, and the ith column, right? So 0th row, ith column. And you can see it's grabbing the temperatures. If the temperatures were instead saved down here, this is row 1. So we would need to change that to a 1. And the reason it's being changed by this linear factor is that I found the thermometer wasn't quite calibrated to boiling melting points, so that's just a correction. That's the big one. Let's punch it, see what happens. We got an error already. That's lovely. Okay, so working on Extrema A. It didn't like it. Okay, so know how I was saying we can investigate things with this individually graphed Extrema? Let's do that. So we got its error in Extrema A. So I'm going to tell it to graph A. Okay. So let's see what went wrong here. That's fine, that's fine, that's fine. At that point, you could see how its fit was just a line. It didn't do a proper fit there. And I'm guessing that's because there's not enough data points. I'm going to try upping the range bit on that one. So instead of grabbing 97, I'm going to say, I don't know, let's do 120. And the reason I'm guessing more is that I actually have a function where if the curve fit doesn't work at first, it's going to try to shrink the range. So if that didn't work, maybe increasing it will help. So let's try again. Oh, it's going. All right, so we didn't get all the way through this time, but oh, look, it's generating graphs. Yeah, I'm gonna have to change that y-axis thing. Okay, so I'm back after I had to leave for a while. One thing I did change is about this spectrograph intensity max. Um, so previously I just had it as that's how you set the y max for all the spectrographs, and it was always a constant. But as you saw, sometimes it would go over that. So what you could do now is set this to a negative number, and then that'll allow it to just set the y-axis dynamically. So I'm going to leave it like that for now. Anyway, I think last time we ran this, we encountered an error, but hold on, actually, I'm going to halt this. Unless I know that there's an error in a particular extrema, it takes ages to do the individual graphs. So I'm just going to tell it to not do that. Bum, bum, bum. Okay, now let's try. Go in, and we encountered an error again. This time in extremum D. Okay, so let's have it show us D. Go again. Yeah, again, it's not working. It's strange because that looks like a Gaussian, right? So first thing I'm gonna try is increase the number of points. So 100, and I noticed it was decreasing a lot for C. Oh, yeah, but C is a weird one. Okay, I'll leave C alone. Let's try that again. I think we made it all the way through. Just watch this play out. And you can see how the y-axis is kind of going up and down a little bit. And again, that's because I set the max to a negative number, which says let it be whatever it needs to fit. Awesome. So I made it all the way through. We are nearly done. I'm going to close all these. I'm going to tell it to not do the extrema anymore. Run it one more time just so we can see the pictures without being interrupted with all the spectra. Boom. And here we are. All right. So this is everything. Now that there's no errors, we're ready to export. So let's go ahead and set do export true. Or if you want to be fancy, you could set it to just 1. And it's going to run again. There we go. So now if we head on over to the folder we assigned as the results path, right there. Boom, look at that. So first of all, we get all of the pictures we generate. I'm just gonna put that into a new folder. Okay, you see we generated a couple different CSVs here. These first ones, like I'll open up first heating here. This is the can't open the same thing at the same time. Okay, that's a good point. Closed the other one, I think. There we go. So here we could see for the first heating, for each temperature, we could see where each peak was located, right? So if you want all of just the raw data, you could turn these into the graphs. For example, scatter plot, boom. And that should match this one. See? So that's that. I'm not going to save. So all of those are the same. It's just the points over temperature. And then these three are the slopes, the standard deviation of the slopes, and then the R-square value for all of these line fits that we're doing. Okay? So let's look at the slopes, for instance. Wow. Like first heating D had a slope of 0.000216 nanometers per Kelvin. And then 0.003, 0.003, 0.002, 13, -50. Yeah, C, we all knew C was kind of whack to begin with, so I'm not too worried about C. Here they're all negative. Here they're all negative. Oh, no, that's a positive. That's not fun. And then, like, for instance, R squared to see if any of them were actually nice linear fits. Which, looking at the pictures, not all of them were. Oh, there's R squared. Yeah. So, like, that first one, 1A, pretty obviously not a very good correlation coefficient there, right? So, nearly zero. A for the first cooling was actually pretty good. Let's see if that corresponds here. Yep, so we can see that was a pretty nice line. And so on. And all that's left is to take all this data and throw it into a PowerPoint or into a single unified sheet or something if you'd like. But yeah, that's it.